Okay, so I'm going to just be working on some problems which involve half-angle identities. Um, yeah, I chose those just because I feel like those are the most to complicated identities to use out of all the ones that we're actually using in this section. I feel like the sum and difference ones are a lot easier for some reason. It may be personal, but maybe other people also feel like these are the most complicated ones. So, for this section, these are the most complicated for me. And I'm just going to work on some problems, give some example problems, utilizing each half-angle identity, the cosine, the sine, and the tangent. Um, and that's it. Okay, so in this first example problem, it's just asking to find the value of sine 15. And what we're going to do is just look for the half-angle identity that goes with this. So we can narrow it down pretty easily. It's sine a over 2. That corresponds with what we have here, sine 15, because sine 15 is sine a over 2. So, sorry for that clicking. I have to use this laptop. Oh man, I'm sorry for for this perfect drawing here. Or I don't even have to put the sign right here. A over 2 equals 15. We need A for the rest of the formula. As we can see, 1 minus cosine A. So we're going to find A. Pretty simple. What divided by 2 equals 15? It's 30. 30 right there. Okay, so with that, we can solve the rest of the problem. And bear with me now. I'm using a mouse pad to write this. Okay. Be 1 minus cosine 30 over 2. And cosine 30 equals square root of 3 over 2. We know that because by now we should all know the unit circle. So cosine 30 equals square root 3 over 2. We're now going to fill that in the place for cosine 30 in this equation. So 1 minus 3 or square root 3 over 2 over 2 again. We'll just separate each of these. Man, my drawings are just getting worse as I progress through this. But let's just try not to pay attention to that. Gotta pay attention to the math. Okay, so square root can't be on the bottom. Multiply it on the top and the bottom. And most likely we'll be using a calculator for this. So it just comes out 2 minus square root of 3 over 2. And we still have this plus or minus. And how to decide if it is plus or minus, we just look back at that degree and it's 15, and that's in the first quadrant. And all signs are positive in the first quadrant, so this is positive square. Let me just, maybe I should, this is positive square root 2 minus square root 3 over 2. Simple as that. For this problem, it may go a bit smoother. I got a normal mouse now. Okay. For this problem, it's basically just like the other one. Instead of sine though, it's let me change that. It's cosine. 165 degrees, which is in the second quadrant. That does not look good. Which is in the second quadrant. That's better. Okay, maybe this. Okay, that's a lot better. Okay, second quadrant, cosine. Just like the other one, we're just going to look for the identity, or the half angle identity that correctly matches with cosine. It's just cosine a over 2. And just like the other one, a over 2 equals this degree. Cosine a over 2 equals cosine 165. So a divided by 2 equals 165. We just have to figure out what a is for the rest of our equation, and that would just be 165 multiplied by 2, which, did my equal sign a little too early there, which is 330 degrees. So now we're gonna write out the rest of the equation. And there it is. Okay. We want to find cosine 330, which is actually the same thing as in our other problems, square root 3 over 2. We're going to fill that in for our cosine 130, or sorry, cosine 330. Why did I say 130? Okay. There we go. And like the other one, we're gonna split these two things up. And then can't have that square root in the denominator. Okay, so we do all that junk, and we end up, it actually turns out to be just like, turns out to be just like, oh my gosh, turns out to be just like the other problem we just did, except, let me finish this. In this case, the angle 165, like I said, is in the second quadrant, and only sine would be positive. So, the value of cosine is going to be negative. So, the answer to this question is negative square root 2 minus square root 3 over 2. Moving on to our third question, we're asked to find the exact value of tan pi over 8. Now, I'm just going to convert this pi over 8 to a degree, just so this can be a lot easier. So, just use that little formula, and we get 22.5 degrees. Now, we have tan here, so we're going to have to look at our half angle identities and look for tan. And there are 3. And what do they form? A triangle. It's because it's Illuminati. Anyways, each of these tans, we can use any of them to solve for tan. And I just chose to use this one. No particular reason, it's just wanted to use that one. So we're going to need A. We'll just do the basic thing that we've been doing this whole entire time. A over 2 in this case equals 22.5. So, to find A, we just multiply A over 2 by 2, and we get 45. Okay, so we now have a, it is 45, and we're going to want to plug that into our equation. So before we even do that, we should probably find sine A and cosine A. So let's add a little color in here. So sine A, sine 45, will equal square root of 2. And it's not square root of 2, sorry, square root of 2 over 2. And we know that because on the unit circle at 45 degrees, sine equals square root of 2 over 2. And actually, at 45 degrees, cosine does as well. So both cosine and sine equal square root of 2 over 2. So we're going to just write out our equation and fill in those numbers. So square root of 2 over 1 plus square root of 2 over 2. Now, that looks like a disgusting mess, and it is, but we're going to try to compact it all. So, I'm just going to leave this as it is, but in the denominator, I'm just going to add 1 to square root of 2 over 2. And what I get when I do that is square root of 2 plus 2 over 2. Now, this basic form of this fraction, it's basically it's a over b over c over d. And we're going to use that in order to get this. Multiply d with a and b with c. So we have, we have a, we have b, we got c, and let me find a color for this, and we've got d. So we're just going to rearrange our little formula that we got over here, and we're going to have square root of 2 multiplied by, multiplied by 2 over 2 times square root of 2 plus 2, and I put these in parentheses. These two twos, they cancel out, and they leave us with square root of 2 over square root of 2 plus 2. Now, we still have this square root in the denominator. So in order to get rid of that, we're going to have to multiply this entire fraction by its the conjugate of the denominator, and that would be negative 2 plus square root 2. Oops. Okie dokie. And that equals a lot bigger thing, but I'm just gonna kind of set it up right here. You just distribute all that, multiply, blah blah blah. Everyone knows how to multiply. All you have to do is multiply, and you should come up with 2 minus 2 square root 2 over square root 2. Now, this is a really long problem. This is just going to equal 1 minus square root 2, because you do all your fraction stuff, but you have that negative square root, we need to change this. Negative 1 plus the square root of 2. And that is the answer to this disgusting problem. On our fourth example, it kind of gives us a question, making us utilize the half-angle identities in a different way. So, we're given sine 48.56 over 1 plus cosine 48.56, and we're told to use that identity to write an expression, or use an identity to write a single expression for that. And by that, I mean, didn't mean to do that. And by that, I mean this. So, it's a lot simpler than it seems. We see that we obviously have an angle, and we can just say that that is a angle A, or angle alpha. Yeah, angle alpha. That does not look like an alpha, but that's angle alpha. So we're just going to look in the half-angle identities, and we're just going to see which corresponds with sine alpha over 1 plus cosine alpha. And it's really easy to find that. So it's right here. Instead it's sine A over 1 plus cosine A. So, okay, we have that. What do we do now? Well, this equals tan A over 2. So this equals tan A over 2. Or we can just say for us alpha over 2. And alpha in this case is 48.56. So 48.56 divided by 2, that is 24.28. So A over 2 is 24.28. So we have tan 24.28. This equals this expression right here. So we have found we have used an identity, and to write the expression as a single trig function, which is tan 24.28. So for the final problem, it's a bit long. First of all, let me just change this. This is cosine 2 alpha. So, given that cosine 2 alpha equals 1/4, and A terminates in quadrant 1, which is just saying alpha is in quadrant 1, find the exact value of sine alpha. So, first, what we're going to want to do, we know the value of cosine 2A, and we're looking for sine, I'm just going to say A, not alpha, and we're looking for sine A. So we're going to use the half angle identity. Where is it? Let me get a little colorful. Sine A over 2 equals plus or minus square root 1 minus cosine A over 2. So let me go back to this. Let me just write this out real quick. So once we have this written down, we have to keep in mind that we don't have cosine A, we have cosine 2A. So we're just going to tweak this formula
in order to be able to put cosine 2a in here. And it's pretty basic. Since we're having 2 times our angle here, since we're going to have 2 times our angle here, we're going to have 2 times our angle here as well. So the equation is going to look like that, plus or minus square root 1 minus cosine 2a over 2. And we know that we already know that cosine 2a equals 1 over 4. So we're just going to fill that in for cosine 2a. Okie doke, over 2. And subtract 1, or subtract 1/4 from 1, it's 3/4 over 2, like we were doing in, well, first let's simplify that a little more. And that would just be 3 over 8. Now, like we were doing in all our other problems, just split up these roots, and we want to get our root out of the denominator. We just add a little color. Okay. Now we'll have square root 6 over 4. Still plus or minus as of now. Now, to determine this, it's easy. We just look back to what it told us. A is in quadrant 1. So, every angle is going to be positive. So, for this, our answer for what sine is would be 6 over 4. Or, sorry, square root 6 over 4. So, those were all the example problems. I tried to incorporate problems including radians, incorporated problems using sine, cosine, tangent, added a mix on things, and I provided the actual half angle identity and asked for, tan a over 2. I did as much as I could to provide a better understanding of what to do in certain situations with half angle identities. And throughout that, I learned a lot more about the half angle identity. It's actually pretty simple. It's a lot more simpler than I thought it was originally. And just keep in mind those certain examples, and you should be able to understand about every half angle identity problem. So that's it. I guess I should end this with some style. You just listened to probably a 12-minute video of me talking monotone, so I'm just gonna give you a little smiley face for being a champ. Good job. That's a thumbs up.